Hello, everyone. Thank you for joining today. We're just going to wait one more minute or two, and then we will get started with Alan talking about PTP 550 today.
All right, let's start. Okay, good morning, everyone. It's Alan Yu. I'm the product manager from Cambium side, responsible for a point-to-point portfolio. Today, we're going to talk about PTP 550, and actually, our expert on this product, Sagar, is not available today. So, we will try to answer as many questions as possible. But there's certain questions I can't address. I will take the notes and we will go back to you. Um, so today is 550. We're gonna cover a few things. The first one is why we built 550. What's the reason behind that? And then we're gonna do a very quick overview for PTP 550 about the channel bounding and interference mitigation. Then we're gonna share 5 of the use case, or we deployed 550 in different countries with different scenarios, and then we will provide an update for roadmap. All right. First, so why we built 550? Largely it's about data. It's about capacity. So today, if you look at P2P portfolio as a whole, before 550 was introduced, the highest capacity we have is P2P 670, which gave you 450 meg capacity. But we know the data, we see the requirement for more data, more high capacity backhaul need to be deployed. And because, all is about data. That's every year, the demand for capacity is increasing. So we're looking for a solution can deliver gigabit throughput using the 5 gigahertz, which means is we need wider channel and we can support. And also we have to face the issue about interference because 5 gigahertz is unlicensed band. To do that, we come up with idea for 550. So for 550, it's not a single radio with one channel because as we said earlier, 5 gigahertz as a whole is unlicensed, and there is a lot of interference. If you have a super wide channel, say you have 80 meg or 100 meg or 150 megahertz channel, then some interference will be covered in that channel because you can't find a really clean channel that wide. That's bring the challenge. So when we bring the 550, when we think about high capacity, and when we think about we need more bandwidth for the channel size, actually we think we want to build a dual core radio. So the 550 has 2 independent channel or core inside the radio, and those 2 channels can be adjacent or non-adjacent. And this 2 channel can be on different frequency, 5.1, 5.2, 5.4, or 5.8. By doing that, we will be able to really, find a relatively clean channel within the channel size. You may never have a clean 80 megahertz channel, but you may be able to find 2 of the 40 megahertz channel. You may never get 2 of the 80 megahertz channel. Let's say you can find one on the 5.1 or 5.4. You do have a clean channel for 80 megahertz, but you can't find the second 80 megahertz channel. For 550, we can do 80 megahertz channel plus a 20 megahertz channel or a 40 megahertz channel. And because we already have the 2 totally independent core, the channel size, the channel modulation is totally independent. That gives 550 the best or the flexibility to fit all different cases. And that gives us the gigabit capacity as well. So that is we're really, when we designed the 550, we were thinking about this way, and that is where the whole foundation was based. And then if you look at the 550, that is we call this feature asymmetric non-adjacent channel bonding. Very, very unique. And then we have the other things. We have the asymmetric modeling. As I said earlier, the channel is totally independent. One channel works on 255 megahertz. The other channel can be on 60 megahertz channel. So it's not a problem. We also offer the fiber interface. It's all about capacity here, right? So when we think about, you need when the radio deliver a gigabit throughput, how are we going to connect to the radio? We have a copper interface, but also we give them the fiber interface because many customers they would prefer a fiber, not only because sometimes the tower interference thing, so they want to have a fiber in place rather than copper thing. But also, they want to reach longer distance. Fiber is another way you can do a longer distance. And we understand it's unlicensed band, so we implement the ARQ protocol, so the data will be able to retrans. So later in the use case, when we share the use case, you can see um, in the area where there's a lot of interference, ARQ really make the difference. And that is where even when we do our own comparison with our own PTP 450 or PTP 670, in a certain case, one radio will overperform the other. On the other case, one radio will overperform. Like one of the case we have is 550 overperform 670 on the same channel size. The reason is because of ARQ for that specific deployment. Very interesting stuff. And the last one is you can see the picture here is we have two radios. One is integrated version with a 12-foot antenna, 12-foot, 12-inch antenna built in. It's a 12 by 12, 23 dB antenna built in. And then we have a connectorized version. So you will be able to connect with external antenna if you need a higher system again. When you purchase a radio, every radio will come. Every radio actually is not a radio, it's a kit. It includes a radio. It includes a power supply, PoE power supply AC version. It also have the mounting bracket and the line cord. Depends on US, UK, European, or so we have four versions: US cord, UK cord, European cord, and also a radio without cord. So depends on which country you deploy, and then you choose the right kit to fit your needs. So let's talk about channel bonding, because that is a very, very unique thing on 550. As I said earlier, we support different channel size, and channel A and channel B is totally independent. The channel size we support is 20, 40, 80. So you can and because they're totally independent, you can have all different combinations. So here list the combinations we have, and of course if you're running the highest capacity, you will running 2 of the 80 megahertz. If you're running the lowest one will be 20 megahertz, 2 of the 20 megahertz. So that throughput on the top modulation mode is from 350 megabits to 1.4 gigabits aggregated. So in the real deployment, because of the RF conditions different, and also because of the available channel on each spectrum. For example, 5.8, right? 5.8 that's 125 megahertz channel, 125 megahertz spectrum available. You can't fit 2 of the 80 megahertz in there because you can't overlap the channels. So you have to do one. Let's say you choose one of the 80 megahertz in 5.8 gigahertz. Then the other one, if you want to do another 80, or you have to find 5.1, 5.2, 5.4 somewhere. So there is a selection about where you want to be. Today, the PTP 550 support fixed mode, or meaning is you have to set up the frequency manually. So you're gonna determine where is my channel A and where is my channel B, and what is the channel size I'm gonna support. So, and we have a built-in spectrum analyzer So you will be able to run the spectrum analyzer to see which two channels you want to be, and then by look at that, for example, in this example here, we chose the 40 megahertz on the 5.8, and we choose the 20 megahertz on 5.1. So and then we combine together. Later this year, we're gonna introduce a feature called DCS, Dynamic Channel Selection. Dynamic Channel Selection, what this feature do is instead of fixed channel frequency, the radio will do this automatically. So it will have its own intelligent to decide what channel size it should be and what spectrum the channel should stay with, and it will continue to scan the spectrum. And once it fit the criteria, it will move to the new channel. So that's the feature we're introducing. But right now on 550, it's fixed frequency. So you have to, so when you do the installation, after installation with the frequency scanning thing, you should determine where the channel is. By doing so, you will be able to, basically choose what the channel size. If we go back to previous slides, the idea is if you're very bad interference, uh, the noise floor is so high everywhere, then you may want to choose a narrower channel because it takes less interference and it gives you a better throughput. Or you have certain spectrum very noisy, say 5.8 is very bad, but 5.4 is good. Then you may want to move your thing to 5.4. You can also do the combination for 80 with 20 or 20 with 40. Try to basically depend on your own situation, give you the best performance. And so that is this is resilience or how you do the channel planning thing. If we have DFS, right? For the DFS, when we have detected the radar, the radio has to shut down and wait for certain period before it can retransmit. And because we have two core there, you don't want both. Well, we would recommend you don't put two of the channel A and channel B, both on a DFS channel. And you can put one on DFS channel, the other one on a non-DFS channel. So in the case when the radio detect a radar, it will only turn off the DFS band, the channel, and you still have another channel keep transmitting. So your link is up. When you have those situations, you're not lost the total connection. You just lost some of the capacity, and when the time is out, then the DFS band will come back. Then you have your full capacity. So it's another way you can see is how you want to play with the dual core, because this dual core give a lot of benefit compared with like 670 or 450. It's a single core radio. When you have the DFS, you have to shut down. You lost the whole connection. With the 550, this gives you the flexibility there. So let's talk about interference mitigation. Interference mitigation, the first one is I want to mention is ARQ. So how ARQ works, it's pretty simple. I mean, ARQ is we have been using this one since a very early day when back to the canopy days, when the IP packet dropped, and the radio will be retransmit until it's ready delivered. So when you have the bad interference, and then you want ARQ to help to correct those dropping packets, so the dropping packets can be resent. That is the ARQ. The other one is load balancing. We said earlier, you lost one link, you don't lost the whole you lost one channel, you don't lost the whole link. So with the channel bounding, we put one channel. If we don't, we can put one channel in the less interference area, give you the kind of like a guaranteed or more secured throughput. You put the other channel in the area like DFS band or whatever, where you may suffer a loss or a disconnect when certain things is triggered, but you never lost the link. Of course, the radio also support adaptive modulation. So when it's 3 dB per step, so when we detect the interference change or the RF condition change, the radio will shift the modulation up and down to try to give the best performance. And all of this is totally independent. So when channel 1 running go down because its interference go high, channel 2 will stay if the channel 2 interference doesn't really change. So that is the adapt modulation stuff. So if we look at the thing on 550 as a whole, before we jump to the case study, I just want to highlight a few things here. The two thing, the very, very unique stuff is the channel bonding. That's the most important one. And other thing is the ARQ. We're adding the QoS in the next release. It's coming very soon. And then later this year we have the dynamic channel selection DCS, and that will basically give you all the tools, all the major tools you need for a 550 deployment. With that, let's talk about some of deployment we have. So this is the case deployed in Argentina with two of the 20 megahertz channel, and the TD cycle is 3070. They're using a 31 dB antenna on both ends. So you can see is the link performance is 217 megabits with two of the 40 megahertz channel. The link distance is about 30 miles or 49 kilometers. And this is pass link planner pass profile. So you can see is one is down to the one is on the top of the it's not necessarily a mountain, but it's just the terrain is very high, and the other one is low. And this is one example. We can do pretty good throughput with a long distance deployment. Next one I have is a deployment in Croatia. So this is a short link. It's a 5 kilometers or 3 miles distance. In this case, we're using a wider channel. Two of the channels, they're both 40 megahertz channel. And the TD the scheduler is 3-to-1, so 75 versus 25. In this case, there's two antennas, a 29 dB antenna, and we achieved 650 megabits in a combined 80 megahertz. So you can see it can also fit 550 very well for a middle range link with two of the 40 megahertz and deliver 650 megabits throughput. Next one I have is in India. So this one is about 11 miles distance link using a single 20 megahertz channel. The unique case for this one is the interference is very sharp, short period. It's like every there's a pause here, then it's become quiet. Another pause here, become quiet. So it's a very strange or very unique situation. In this case, actually, we did compare the 670 with 550, and in this specific cases, 550 provide a better performance than 670, and partially it's because the ARQ was there. And this one is we using two 20 megahertz channel, a single 20 megahertz channel with a 29 dB antenna, and we get 144 megabits throughput in this case in India. Next one I have is in US. So this is a short link. It's only a 1.4 miles link, a very interference area, and we're using two of the narrow channels, two of the 20 megahertz channel with a 24 dBi dish. And actually, if you look at the picture, it's intact version, and the total throughput is 320 megabits in this case. Next one I have here is the Malaysia. This is in Malaysia as a 5.5 miles link. This one using the full 80 megahertz channel for both channel, and it's also a very high interference area. But we do manage to get two of the 80 megahertz channels there. With that, we get a totally 425 megabits with downlink 348. So this is one of the deployment over there. So here's a summary about all the deployment case we have. What we're trying to show here is different channel combinations and also the different distance, different interference, and you can see is India is a very unique one. They have this pulse interference thing. The 18 kilometers, we running single 20 megahertz channel is 144 megabits. It's 7.2 bits per hertz per second. And then when we're using the 12 to 80 Malaysia, it's also very bad interference. We managed to using 12 to 80 megahertz channel. We managed to get 400 megabits throughput. So it's just a recap about the use case we have deployed. Next one, I want to recap the roadmap here. So we have the 4.3.1 published on the support web page, and you should be able to see the 4.3.2 also there. The 4.3.2, what we add there is the FCC and FCC DFS, and we also have the ICDFS just granted, and that will be published very soon there. In together with 4.3.2, we have the QoS feature added. So there are some other bug fix for the radio optimization stuff. But big thing in the 4.3.2 is FCC and IC DFS. The radio already we got a stamp, so that is where we can officially release it. And the QoS is there. The next major release, what we have is the 4.4. Actually, this one is not right here. It's not Q1 date. It's more in the earlier Q3 date. The final date is not finalized, but that is coming. The basic DCS support. So for the dynamic channel selection, there will be two phases. Phase one, we will deliver those, some we call the basic DCS support, and phase two is enhanced DCS support. And we are evaluating the details about which one will be in the phase one, which one will be in the phase two. So once we have those details finalized, and we will have a more solid date we can put in, and we will share with you guys next time. But DCS is coming in the second half of the year. So when the radio detect interference, the radio will make the choice for both the channel size change and the frequency change. So for example, if I'm running on 5.8 right now, I have high interference, but I found 5.1 is cleaner, and I will move my channel from 5.4, 5.8 to 5.1, And also when I make the change, depends on the real situation in 5.1 spectrum. If 5.1 can have a clean channel can support 80 megahertz, then we're gonna provide a 80 megahertz. If the channel one has a much, only be able to do a 40 megahertz, we will do the 40 megahertz. The general criteria is really, no matter what we do, the newest channel should provide a better throughput than the existing channel. Otherwise, why we move, right? So those are the common logic there. But the details about, we're gonna support it and what kind of criteria customer will be able to set, and those details will be reviewed once we have the next time when we update the roadmap. So this is about 550 roadmap in this year, and the big one is the DCS in the second half of the year. That is the end of my deck here. I'm gonna open the Q&A, and if you have any questions, please put the question in the panel, and I will go over that. Okay, so we have one question here. The question is it less than 5 kilometers? Well, of course, it can support more than that, but I'm not sure you refer to a specific country or specific spectrum. But you can see is, we have radio deployed in different country and different world, and we have different, we certainly can reach much longer than 5 kilometers. All right. What dishes are recommended? The second question I have here. So, generally speaking, we carry the radio wave antenna. So we recommend radio wave antenna. You can find the part number from Cambium price list, and we have the all the antenna we carry is dual pole because of the this is a MIMO thing. So we have both D and H. You should be able to find that. We have, I think we have 2, 3, 4, and 6 foot. All right. Next one I have is another question is, can we know how far apart? Oh, I think the next question is, what is the channel separation between those two channels? I believe right now we can do, well, let me take it back. We can put the two channels very close to each other. I do not remember how many, do we need 5 megahertz or 10 megahertz as a guard band between, but we can put two channels very close. Let me find that answer and I back to you. I don't remember the final answer for that. But certainly you don't need a whole channel bandwidth for the guard band. If you have 40/40, 12/40 megahertz channels, you don't need a 40 in between. I think it was like 5 or 10, but I need double check for that one. Next one I have here, the question is, a 65-kilometer link with 1 gigabit aggregate requirement can be a support. The question is, can we support 1 gig with a 65 kilometers? Well, it's really depends. So the link planner will be the best tool or the place you can find the answer. So you put your geo data, and then you put your channel size. You put your interference level, because in the link planner, if you're familiar with the link planner, you will be able to choose the antenna size, the interference level, channel size, and it will give you a prediction for the throughput. For 65 kilometers, you need a not only you need a very large dish, but also your antenna heights need to support that, because once you I think more than 40 kilometers, actually you have the Earth curve. So definitely you need to run link planner to see can you reach a line of sight. Without line of sight, there's no way you can do a 1 gig with 65 kilometers distance. All right, so next one I have is a PTP 550 supported in sea and heat? So it is not yet. The sea and heat, the first focus for sea and heat is more on the PMP side, because that will give you the idea about my AP coverage, right? You have a heat map. For a point, the PTP 550 is dedicated for a point. So seeing heat will not bring you more. I don't. Let me take it back. I don't see great value seeing heat added for PTP 550. If you do a point, you know the point A and point B. Link planner should give you the information you're looking for in large cases. One of the seeing heat benefit is LiDAR data, because it's the resolution down to 1 meters. So you really have a better idea about line of sight or not. The link planner today only gave you the terrain data. It's the solution, I think, was 10 meters. And also we do not have all the trees, building stuff. So if you really have the challenge for line of sight, seeing heat will help you. But generally speaking, seeing heat is focused on PMP side. It's not on PTP side. We ultimately in the future, seeing heat will support almost all applicable radios we provide from Cambium. But right now the focus is not on the point. So that is a seeing heat question. I have now another question is on the bandwidth page. Let me go back here. I think the question is on this one. I'm not fully understand the question here. Okay, I think it's questions about channel combination. The idea is, as I said, the two channel is totally independent. So one is 20, the other channel could be 20, 40, 80. Same thing. So your total combination was there are 6 different combinations, and you can on different spectrum or other things. If you are deploying 550 today, and you have in your deployment, you have certain technical questions about where I should do or how I should set my my channel thing, I would recommend call our customer support team, and we have 24/7 customer support team, and they will give you the recommend actions. We also have the product expert team, which is our system engineering team, and they're for the issue or for the complicated deployment issue, and then the support team will escalate to this product expert team, and then we will engage directly with engineering and relate to the product expert to provide the recommendation or troubleshooting on what we suggest you to do for those cases. So call the support first. That will be your contact to start with. All right, I think I got all the. Okay, I have one more question. This question is: aside from integrated antenna, is there any specific dish for high noise interference environment? So generally speaking, as I said, we only offer radio wave antenna, but technically there is no proprietary interface there. Almost all the 5 GHz antenna is N-type connectors. For the very high interference area, we recommend to go with higher performance. There are standard performance antenna, there is high performance antenna. Certain vendors also have this ultra high performance antenna. All they do is to make the slope, the antenna slope much sharper. So you will be, you will be able to get rid of the interference. You can get rid of more interference because most of the interference is very directional. So with the very high performance, ultra high performance antenna, you will be able to reduce the noise on the slope. So the beam width could be a bit more narrower, and the radio performance could be improved. This is not about antenna gain. It's all about the performance or the Q value of the antenna. So that's what the ultra high performance or high performance antenna can bring in. As far as I know, I mean, there's no limitation. Depends on which country region you are in. One of the possible choices to look at the antenna spec, even a local antenna supplier. They may have a good antenna can fit this situation. So that could be a place you can look for. All right. I think that's all the question I have on under the panel. If there's So we will take one more question if there's one, and then we will close today's webinar. All right, I think we're all good. Susie, you still here, or?
Yep, I'm still here.
Yeah, I think we're good for today, and back to you.
Okay, we will be posting the recording and the slides to the community in our YouTube page, so you can catch the replay of this webinar there. Thank you everyone for joining us again, and we'll see you next time. Thanks, Alan.
Thank you. Bye-bye.
Bye.